I had so much trouble today. This really might be my last stream. Welcome to episode 21 of PocketBased. PocketBased is the premier dev channel for all things PocketBase, PocketHost, and PocketPages. In this episode, we add round phases to Kingdom and make it possible to stage attacks on other players. We consider moving to HTMX. We talk about some PocketHost bugs that just came up. Check on the YouTube campaign of it all. And finally, say hi on Discord. If you're new to this stream, they call me Cap. I'm the creator of the open source projects PocketHost and PocketPages. PocketHost is a hosting platform because I didn't want to self-host PocketBase. And of course, irony of ironies, now I'm responsible for hosting tens of thousands of PocketBuy. The project is open source and free, but there is also a paid hosting wing. The paid hosting wing is the one where you can pay to host your PocketBased instances on PocketHost instead of self-hosting. That part costs me money because there's hardware and infrastructure involved, so it costs you money too. We still have some good lifetime deals left if you're interested in that, but you can also get started with a 7-day free trial for a mere $5 a month. So take a chance on PocketHost and we'll take a chance on you. PocketPages is a completely open source project, server-side pages for PocketBase. This is your way to go ultra thin client, ultra old school PHP style, but with a modern twist of a HAP stack, H, HTMX, A, Alpine.js, and P, PocketPages. The HAP stack is the future. We have a really cool Discord community, over 1,500 members. Come join, we'll make you feel right at home. All right, I'm ready. Are you ready? Let's go. Let's talk about the Kingdom update here. So our mission by building Kingdom is actually to build all the things, all the layers underneath Kingdom at the same time. So that's PocketHost and PocketPages, namely. Kingdom runs on PocketHost. If you go to PocketHost.io, this is, like I've said before, this is the open source project, but this is the paid hosting wing of the open source project. So you got to pay to host your projects on PocketHost, and we have some deals for that. I think this is so much easier than trying to self-host, guys. So look, inside here, I've got Kingdom. Kingdom's got live logs, it's got FTP access, it's got everything you need to get up and running quickly with a PocketBase instance. So we're using that for Kingdom. Kingdom is also built on PocketPages. PocketPages is another open source project that I'm doing. It's server-side pages for PocketBase. Server-side pages means like the old PHP days where you would just have a server-side scripting language that would render pages. You can do almost the same thing with PocketPages. You've got copious documentation here, so I think it's pretty easy to get started, but your mileage may vary depending on how much experience you have with this kind of stuff. But the idea is a return to server-side pages so that you can have a very thin front-end client and get rid of that whole build chain. So that means no more React, no more Next.js, no more SvelteKit, no more bundles. You don't need any of that. Instead, you can focus on the HAP stack, which is HTMX, Alpine.js, and PocketPages. So we are also using Alpine.js on the game that we're building. And that's kind of our stack. So let's get into the Kingdom updates. Kingdom has rounds, and each round now has different phases. The first phase is the placement phase. That's where you use your shards to convert them into hearts and get yourself on the board. So I can tap around here. I can get myself on the board wherever I want until I'm out of shards. Once I'm out of shards, it will say not enough shards. So that's it. During the placement phase, that's all you can do is lay pieces on the board. When the phase timer runs out, it will proceed into the assignment phase. Now, in the assignment phase, let's suppose some other players have entered in here and they've placed some of their tiles as well. You'll see that happening during the placement phase. Other people will come in, arrange their tiles. You can stack up and fortify your tiles. The assignment phase is where you decide whether or not you want to attack your neighbors. If I select this guy here, there's nobody to attack. I have to select one of my cells, and it has to be a neighbor cell. So for instance, here I can select my cell, and you see this one's open for attack. So I will click it to indicate that I am attacking with one of my tiles. Now I can also click this one and click again. Now I'm attacking with two of my tiles. But this one here cannot attack anybody. It won't let you. So that's the assignment phase. And then the third phase, the resolution phase or the war phase, is where the game engine decides everything that happened. So let's take a look at the code changes that are powering this. So in the room state here, we've added the concept of a round step. That is placement, assignment, or resolution. Those are the three phases of each round. And you keep track of when the step started and how long that step lasts. Someday when I allow people to create their own rooms, they'll be able to adjust some of these parameters, like how many rounds there are, how long step lasts in each round, whether there are hidden prizes or not. So let's take a look now at the front-end changes. First of all, the time remaining is now calculated based on the step, not the round TTL. Then we have this concept of a selected index. The selected index is the cell that the player has selected that is currently active. Then we have some logic here to gather up all the neighbors. So for a given index, who are the neighbors to the north, south, east, west, and all the diagonals? All right, we have some tests here to see if a player owns a given cell or if the given cell is an opponent cell. We have a function to gather all of the neighboring opponents of a given index, of a given cell. We have a function to toggle the neighbor attacks. If I'm here and I click this again, you see it toggles back and forth between 2 and 1. That's the toggle. So you can toggle a neighbor attack on or off. And then handle click has gotten a little more advanced. Let's step through this logic. So if we're in the placement phase, no problem. We just call the join function just like we did before. But if we are in the assignment phase, there's a couple different things that happen. First, you have to select one of your cells, then you have to select an action on one of the opponent cells. If the player's own cell has been clicked on, then that becomes the selected index, and we gather the neighbors for which we can take some kind of action. If I click on this cell, there are no actionable neighbors, but if I click on this cell, you see the red throbbing box means there's an actionable neighbor. If I click away, the neighbor is not actionable anymore. If I try to click this one, it won't let me. I have to click my own cell. If I click my own cell, you see it highlights the actionable neighbor. So that's what that actionable neighbors is about. Now, once I have selected a cell, if I click on a cell and it's not a cell that I owned, but I have selected one of my cells that I do own, then we toggle the neighbor attack, but only if I've clicked on one of the actionable neighbors. Otherwise, we deselect everything, and then the error state is select your own cell. And then down at the bottom, we added a bunch of these different cell states for the various game states that might be happening. That's all on the front end. On the back end, in the join handler, I've made some improvements because I realized the whole database gets locked when anyone is performing a transaction. So it's not just the room, it's not just the table or the table row, it's the whole database that gets locked. So it's important to get in and out of that transaction as quickly as possible. And what I noticed here is I was doing some stuff that I could check before I entered the transaction. Like I could check to see if the cell's occupied before I ask for a transaction on it. I can also check to make sure the player has enough shards to even do anything. And finally, when I push these state deltas out to everybody, that certainly shouldn't be happening in the transaction. So I've come up with a different strategy where I've hoisted a lot of that out. I've created what's called a step guard, which means if you're not in the placement phase, you can't join a room anyway. So the first thing I do is check to see if we're even in the placement phase. Then if a cell is owned or empty, that's a different kind of guard. If I own the cell or if it's an empty cell, there's an action I can take during the placement phase, but only if I have enough shards. So there's a shard guard going on here. I combine all three of those checks together into a should attempt join. Good, so then look what we do here. We initialize our room state and our error state, and we grab the room state initially outside of a transaction. Then we say should attempt join. If we should attempt the join, and only if we should attempt the join, then we enter into a transaction. And inside the transaction, we refetch the room state. So we make sure now we have an exclusive lock on the database. We pull the room state. We're about to do something with it, refetch it, and see if it is still valid to attempt a join. Because between the time that we checked to see if we should attempt to join and we obtained our transaction lock, the room state could have changed. So we check one more time while we know we have exclusive access to the room state. Once we have exclusive access to the room state, we do all our stuff. And then here is another difference. I have this deferred function array. This deferred function array is stuff that I need to do if the transaction runs, but I don't want to do it inside the transaction. I don't want to push the room state delta to every single user. There could be thousands of users listening, and I don't want to push the protected room state delta to the authorized user inside the transaction. That takes up extra time that we don't need to take up inside the transaction because we want to get out of there as quick as possible. So after the transaction ends, we run through all of our deferred tasks. This is about as efficient as I can make this transaction logic. The only thing I could do to make this more efficient is drop into Go and program it there instead of in the JSVM, but I think this is going to be okay. So that's what we've been up to for Kingdom. The only other thing I want to mention is, look at this file here called Middleware. This is inside a virtual path called game. I stole it from SvelteKit. It's a way with file-based routing to be able to group things together without it actually being part of the URL path. So this middleware will run for any request inside the game group. And what does this middleware do? Well, it advances the game. And we have a very similar check going here where this middleware is responsible for advancing the game state to the next step of the round. Every time a request comes in, it will have an opportunity to check to see in a transaction, should this round be over already? So see this, it's the same pattern. The step is, we have a step expired guard. We fetch the room state, we check to see if the step has expired. If it has, we enter a transaction where we see if the step has expired again. So what will this do? Two requests come in at the same time. Maybe they both see that the step has expired, so they will both request a transaction. One of them will get the transaction, the other one will not get the transaction yet. The one that has the transaction will work on advancing the step, and once it's finished, it'll save that data. Then the other one will receive us to its exclusive transaction. It'll pull the new game state and it'll see, oh, the step is not expired, meaning somebody else already updated it, so I'm going to bail out of here. So it's a very efficient way of handling transactions. And then from inside the placement phase, we advance the game. For right now, the middleware does not advance to the assignment phase because I'm just leaving it safe for players to jump in and try playing the game in the placement phase while we're still working on the assignment phase. All right, so those are the Kingdom updates. Well, almost. You know, I'm getting a little stressed about Alpine here. There's a lot of init code and a lot of state management code here that is already mirrored in the DOM, and I'm curious whether a move to HTMX might be better for us. HTMX would be a pretty serious refactoring at this point. Our API endpoints would need to change as far as what they return. The real-time data and deltas would need to change what they return. So I'm not sure yet whether I'm just struggling to organize everything or if there's something more going on. I mean, one kind of technique I can do is I can take functions like this and I can hoist them up into a script section. Here's another method that actually doesn't depend on access to the state, so we could hoist that one up here too. Yeah, so that works. I can hoist a few things out of there. I'm curious too if I can get rid of those this references by making a lambda instead. What happens if I do that? Yeah, it didn't like that. So it looks like I'm actually able to hoist the entire game state out of the template, and at least I just have the init code left in here. All right, this is actually a pretty reasonable refactoring here. So I learned that if you provide an init function inside of your state data, it will call that instead of xinit. So you don't actually need the xinit up top here. You could just have an init function inside your xdata and it'll work fine. I've hoisted out all of the big JavaScript stuff. So we have a really simple template here to render, and then we have all this JavaScript up here that manages the game state. It's a lot of this dot that, but I feel okay with that. We can even hoist out this function apply deltas and just feed it a room state. So down here, when those deltas come in, we can just apply it to the room state. I'm looking for ways to keep this game state blob as organized as possible. So let's test one more time and see how we're doing. Yeah, works great. Perfect. So let's whip this and leave it there. Now we can move on. So just to close that out, I think I won't move to HTMX just yet. I'll stick with Alpine.js. I don't see a need for HTMX just yet. Taking a look at our channel, we have almost 150 subscribers, and let's see how the shorts performed that we posted yesterday. Yeah, see, these shorts just stayed pretty focused on our smaller community. If we start going out there and talking about crypto, we'll definitely pick up more people, and that's necessary because we are making a game that is not just for the developer community, so I do want to post and hopefully make some videos about this go viral. But for now, I think we're taking a little breather. The only other thing I'll say is I kind of like this brighter approach, like more visible thumbnails. I like this Hapstack one. That's one of my favorite thumbnails, but I can't say it actually makes a difference. I don't really see that the thumbnail matters that much at this point. So I think we'll just leave it how it is. Lastly, let's check in on Discord. Today, somebody asks, what happens when the instance suddenly stops for 2 to 3 minutes? I have been experiencing this too. I suspect it's in PocketHost, where my proxy code is somehow getting disconnected from the Docker container, perhaps through some race condition, and it is just hanging. There's no timeout, there's nothing, it just hangs. And eventually, after a few minutes, it does resolve. That corresponds to these uptime things we keep getting. PocketHost is down, PocketHost is back up, down, back up. Requests are not getting forwarded through to the container properly. I went to try to debug that, and I found that there's another bug standing in the way, which is that the log files are not logging the metadata for each log entry correctly. So before I can even troubleshoot this, I need to go back and fix that bug. I'm eating my own dog food. I notice it too. The difference is I can go into the PocketHost code and into the PocketHost server and troubleshoot it where you guys can't. So it's a much less frustrating experience for me, but still a pain point. And I have to balance that against how much dev time I want to spend maintaining the old code base that I suspect is going away, because we're working on this new container technology written in pure Go named Pocker, and it's already out there. It's already live. It's happening. We're already proxying all the traffic through it. There are 40 regions around the globe. So it's already been deployed. And it's like, if I fix this bug, I'm really just fixing this bug for the legacy free users that won't have access to the new Pocker network, where they'll be stuck on this single instance of an old machine with old code, and I'll maintain it as best I can, but it's not the way forward. So there's a little bit of a question about how to invest my resources because I don't have unlimited time. I certainly notice it when I'm developing Kingdom, but my thought is maybe I should just move Kingdom onto Pocker and eat my dog food there, because that's the future of the platform. The other thing to announce is that we've got 2 guests that are scheduled to come on to the live stream in the next couple weeks. So that'll be a lot of fun. And in fact, there's a 3rd person I need to invite after I jump off here. So with that in mind, I'm going to stop the stream and record the intro, and we'll see you guys next time.